So, Unit 5, Day 1, Properties of Exponents. But again, the caution is, or the warning, is we have a test next block day. So, October 26th for you guys, 27th for the even block people. All right, properties of exponents. This is definitely review day. You should definitely know all of this. We'll sort of extend it later next week, but it's a great lesson for a Friday, especially a pep rally schedule Friday. I hope I'm not overselling how easy this is. Find out. X to the n times x to the m. Do you remember what you do with those exponents?
Try to show us the screen.
You add still on your.
No wonder.
Oh, so we're supposed to be taking notes?
Yes.
Okay.
Sorry, I froze the screen to do something and then left it alone. Somebody said it. What do we do with those exponents? You add them. So that would be x to the n plus m. You know what? Let's number these. How about x to the n raised to the m, a power to a power. You multiply them. X to the nm. Here's one that gets some people. A negative exponent, what does that do? 1 over x. It flips. Whatever has the negative exponent gets flipped. Word of warning on that one. I mean, I've got more examples later, but this is what messes people up. 2x to the negative 3. How do I write that without a negative exponent? Where does the 2 go is the basic question in the top. Because the 2 does not have a negative exponent. Only the x does. So the 2 stays in the top, and the x cubed goes in the bottom. All right, your brain, I guess, is used to seeing 2x and not realizing that that's 2 times x. So the 2 stays where it is, and the x cubed would go to the bottom. What about x to the 0? 1. And then x to the n over x to the m. X to the n divided by x to the m. You subtract the exponents. The top one minus the bottom one. Okay, let's do some examples. Prove that we know all this stuff that we claim that we know. Start with an easy one. X cubed times x to the 7th. X to the 10th. How about x cubed over x to the 7th? Good. X to the 4th, but in the bottom. So you still subtract, but you put it where the bigger one was. Thank you. So 7 minus 3 is 4, but there were more of them in the bottom. So x to the 4th in the denominator. And I'm only going to show this once because I don't hope nobody needs this. But if you absolutely really got stuck, x cubed is x times x times x. X to the 7th is 7 x's. And then you could cancel 3 of them. And sure enough, you're left with x to the 4th in the bottom. I don't think anybody, I hope no one needs that. But if you get stuck and you're a brain lock somewhere, you can write it out and then sort of figure out what the answer is supposed to be. X cubed over y to the 4th, all to the 7th. Yep, x to the 21st over y to the 28th. Power to a power you multiply. What about x cubed over y to the 4th to the negative 7? Oh, look at you guys skipping steps on me. Yes. If you need to see where that comes from, I would distribute first, and then anything with a negative exponent flips to the other side. But yeah, you could sort of omit that step if you could handle it all at once. Okay, well those were mostly like one or two things at a time. Let's step it up a little bit here. 3x cubed y squared over 27x to the negative 6 all squared. So that looks fun. 3x cubed y squared over 27x to the negative 6. Well, what do you want to do first? There's two options, and they're equally right, but JD, what do you think?
Take out the 3. Take out a 3. Or would you not want to do that? Oh, never mind. You want to square.
You mean handle that?
Yeah.
Okay, I wouldn't phrase it as take out a 3, although I like that you're looking at that. I would reduce that.
Okay.
So 3 over 27 would be a 9 in the denominator. What about? So basically, I'm thinking let's clean up the inside as best we can, and then we'll do the squared thing. So what's this x cubed over x to the negative 6? What does that become?
X to the negative, or negative 2.
No. Let's back up and go one step at a time. X to the negative 6, where does that go? So that puts 6 more x's in the top. So how many x's in the top do we have now? Well, it puts 6 more of them in the top with the 3 that are already there. So it's x to the 9th. If you're thinking subtraction, that's fine, but you need to do 3 minus negative 6. So that becomes 3 plus 6. And the y squared is fine. And then let's square everybody. Although, be careful, this isn't 9 squared. It's 9 times 2 is 18. Thank you. 2 times 2 is 4. But 9 squared is 81. Some of you are going to try to do that all in one step. Be careful. I'm not going to tell you no. I'm just going to say be careful. X to the 18th. Y to the 4th. Number 6. X to the 4th. Y to the negative 2. Z to the 7th. All over x to the 5th. Y to the 0. Z to the negative 6. All to the negative 2. Just start throwing everything at you all at once here. Again, like last time, I think I'd clean up all the inside first and then worry about the negative 2. So what do we do with those x's? Or how did that, x to the 4th over x to the 5th, how does that end up? Yeah, an x in the bottom. All right, so again, I'm cleaning up the inside. I'll worry about that -2 later, just because I don't want to try to do too much at once here. How about the y's? Well, what's y to the 0? 1, so that's pointless to even be there. How about y to the -2? Where does that go? To the bottom. And what do I write in the bottom? Yeah, y squared in the bottom. And then how about z's? How many z's do I end up with? 13. Where? In the top.
So they don't like switch places with each other. They just move.
Only the ones with the negative exponent switch places. So this one switches places because he's the only one with the negative exponent. So this guy moves to the top and then adds with the 7 that are already there. Only the things with the negative exponent switch places. All right, power to a power we multiply. So I'm going to show this step, but this might be a step that some of you don't show. Z to the -26 over x to the -2, y to the -4. And then everyone with the negative exponent changes sides, which is everyone. So x squared y to the 4th in the top, z to the 26 in the bottom. We're starting to get to ones where it's like, that's not really that hard, but it is a lot of steps, so please show some work so that you can keep up with it. Some of you are going to try to skip all of those steps and be like, okay, x to the 4th over x to the 5th is an x in the bottom. -2 makes it x to the -2 in the bottom. I'll flip it to the top and have x squared in the top. Well, yeah, not recommended. Number 7. 32 x to the 4th y over 2 y cubed z to the 8th. And then, of course, we're not done yet. We're going to put all of that to the -1/2. So, like we did on the others, let's not worry about the -1/2 first. Let's clean up all the insides, and then we'll worry about the -1/2. So, let's pick on some people. Toby, what's 32 over 2?
16.
So, 16. Brandon, how about the... Oh, well, there's only one x's. I was going to ask you about the x's, but sorry, that's too easy. How about the y's? Where do the y's... What happens with the y's? How many do we have, and where are they? Y over y cubed. So there's 1 in the top, there's 3 in the bottom. Trying to get help there. 2. Do you know why there's 2 and where they're at? Okay, so let's come out to the side. So there's a y in the top, and there's 3 y's in the bottom. So one of the y's will cancel, and that leaves 2 in the bottom. The other way to do it is to just subtract. 3 minus 1 is 2, and put it where the big one was. So y squared in the bottom. And then there's a z to the 8th still in the bottom. And then all of that to the -1/2. Okay, a couple ways to do this. I think I'm just going to put the negative 1/2 on everybody. So let me do what I'm going to do first, and then I'll say it the other way. So 16 to the negative 1/2, x to the, what would that be? Power to a power. X to the negative 2. 4 times negative 1/2 is negative 2. 2 times negative 1/2 is negative 1. And z to the negative 4. Thank you. The other way to do that problem, slow down, you're still writing, is to just look at the negative and flip everybody, but leave the 1/2 outside. So I don't know, you may not even want to write this down. If you wanted to use the negative sign and just flip everybody, you'd have 16x to the 4th in the bottom, y squared, z to the 8th in the top, but then only a 1/2 because you used the negative. Well, I don't know which is easier. I probably should have finished this method first. So what's 16 to the negative 1/2? Where does that go? That's 4 on the bottom, because 1/2 is a square root, but negative flips it over. X to the negative 2 puts that in the bottom, y to the top, z to the 4th to the top. If we had chosen to only use the negative to flip everybody and then did the 1/2, we'd still get y z to the 4th over 4 and x squared. So you'd get the same thing if you use the all of it, negative 1/2 first, or if you just use the negative first. Either way, you get the same thing. I guess, as always with math, the more complicated the problem, the more routes there are to get to the answer. All right, last one. So you can guess that this one's going to be particularly enjoyable. 32, x to the 8th, y to the 15th, z to the 0, all over 243, x to the negative 2, z to the negative 5, and then all of that to the 2/5. This is the, if you can dodge a wrench, you can dodge a dodgeball problem. So let's see, 32 and 243, that does not reduce. I wish it did, but I'm stuck with that. So how about the x stuff? What does that become? X to the 10 on the top. 32, x to the 10th. What about, oh, there's only one y thing, so that's easy. Y to the 15th. What about the z stuff? Z to the 5th on the top. Because that z to the 0 is 1, that just, why is that even there? All over 243. All of that to the 2/5. Well, I guess at least there's no negatives here or there were negatives, but they're already taken care of. There aren't any more negatives to worry about. So 32 to the 2/5. X to the power to a power we multiply. If you need to come out to the side and do 10 times 2/5, nothing wrong with that. 2/5 of 10 is 4. How about 2/5 of 5? Surely, or wait, 2/5 of 15. 6. And then with z, surely 2/5 of 5 is even easier. 2. 243 to the 2/5. Yuck. Let's see. The bottom number is the root. The top number is the power. So I need the 5th root of 32. You remember what the 5th root of 32 is? We don't. Probably 2, because how many other options could there be if this is going to work out? And then 2 squared is 4. And the 5th root of 243. 4 times 4 is 16. Times 4 is 64. Times 4 is 256. So not 4.
3.
It's 3. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Times 3 is 243. So 3. So annoying, but you're going to get integers, so it's not awful. Or I guess maybe it's still awful. It's not impossible. But I'll grant you awfulness. Take your time. Don't race through. Show some steps. Right? Especially one like that. Again, there are people, probably some of you, you're going to look at that and you're going to do all the x's first. You're going to say, okay, that would be x to the 10th in the top. 10 times 2/5 is 4, so I got x to the 4th in the top. And you're going to try to skip everything. Just be careful if you do that. And know that I can't give you much partial credit if all I'm looking at is an answer. So, show me work. All right, I'll pass out your packet, and then I'll make sure everything is posted in Schoology for those at home or for you guys that need to look at answers.